Okay, part A here, given that the vectors that we've got here are perpendicular, find the value of A, right? So if they're perpendicular, remember, okay, that we use this rule of A dot B equals to 0, yeah? That's what happens when you dot them, you get 0 if they're perpendicular. So if I dot these two vectors here, 5i minus 8j plus 4k, dot that with 4i plus 6j plus AK, right? If I work that out, it should come to 0, okay? That's what we're expecting to get because they are perpendicular. So when you dot them and they equal 0, it implies that they're perpendicular. So if I times them then, 5 times 4 is 20, so times the i's together, and then times the j's together, minus 8 times 6 is minus 48, and then times the k's together, 4 times a is 4a, and of course that then has got to equal 0, right? And you times the I, j's and k's together. Put this then together, I think that comes to minus 28. Take it over to the side so we get 28. So then A, of course, then would be 28 over 4, which equals to 7, right? So we found the value of that constant then. Part B then, it says the line L1, okay, passes through the point with position vector 8i plus 3j minus 7k and is parallel to this vector. So part 1 then, it says write down the position vector, write down the vector equation of the line L1. Now we saw this in the last video, but just to sort of illustrate what's going on here, okay, it's saying it goes through a point, okay, so we could call this point A, right, representing point A, so you know that it's sort of going through this point, isn't it? So we call that A, right, and then it says it's parallel to this. If it's parallel, they're actually telling you the direction of it, okay, so the direction, okay, the direction of this line is parallel to this vector 2i. I don't know why I'm writing it sideways, but it looks a bit better, doesn't it? Maybe. So it's parallel to that vector, if that makes sense. Yeah. So any point on this line will be in the direction of that vector there, okay? Because it's parallel to that one there. But if you remember, to get any point, say over here, this point P, right? Suppose you want to get to point P, which is here, the general point P. Well, to get to P, you'd have to go O to A, wouldn't you, to start with? Okay, O to A, plus then sort of a lambda of this direction. Okay, if that sort of makes sense. So quite simply, to get the vector equation of L1, okay, we call it R, of course, right? So it'd be O to A, which is this point here, this point on the line, 8i plus 3j minus 7k, plus then lambda of this direction, 2i plus j plus 2k. And then I would group the i's together, so we've got 8 plus 2 lambda I, group the j's together, 3 plus lambda j, and then group the k's together, minus 7 plus 2 lambda k. Alright, we've got our line L1. Now what's it say here? Part 2 then. The line L2 has this vector equation. Show that L1 and L2 do not intersect. Okay, so they don't intersect. So what I'll do now is I'll write this down, and I'm slightly off the screen here, but I'll write down this line L2, and then I'll pull it back onto the screen. So if I write it, so I'll group it together. So I've got 4 minus 2 mu I, and then I've got 7 plus mu j, and then I've got 5 plus 3 mu k. Okay, so that's what I've got there. Alright, so if I push that back up, then there's my two lines, and we've got to show that they do not intersect. Okay, show that they do not intersect. Now what's interesting here is, to show that they do not intersect, we need to assume they do intersect. Okay, so we do the opposite, assume they do intersect. Now if they do intersect, then the i's will be equal. Yeah, so we're just going to assume now that they intersect. So let's put the i's equal to each other. That'll be equation 1. Let's put the j's equal to each other. 3 plus lambda equals 7 plus mu. And let's put the k's together. Minus 7 plus 2 lambda equals to 5 plus 3 mu. So equation 2, equation 3. what you can do now is, right, we can work with two of these equations, and we can work out what lambda and mu are. Alright, that would be the idea. Now I'm looking at the three equations here, and I'm thinking, to make life easy for myself here, if I work with equations 1 and 3, okay, the reason why I'm thinking 1 and 3 is because I've got 2 lambda in both of them. Do you see that? So if I work with equations 1 and 3, I can then eliminate the 2 lambda. So I think if I take away 1 minus 3, if I do that, I'll have 8 take away minus, I'm taking them away, 8 take away minus 7, which is 15, isn't it? Because you'll have two minuses there, make a plus. 2 lambda take away 2 lambda was 0. 4 take away 5, which is minus 1. And then minus 2 mu take away 3 mu is minus 5 mu. Okay, so that means then, if I take that over this side, 5 mu, and then take that 15 over, so it'll be minus 16. Okay, so that means mu is equal to minus 16 over 5. Okay, so not very nice, but that's what it is. So then I'm going to sub it in to work out what lambda is, but it's important when you sub it in, only sub it into like number 1 and number 3, right? So if I sub it into, say, number 1, okay, so sub in 1. So 8 plus 2 lambda equals 4 minus 2 times mu, which is minus 16 over 5. So then 2 lambda equals, so I'm going to get my calculator, 4 take away 2 bracket fraction then minus 16 over 5, okay, and then if I take that 8 over as well, minus 8, so we've got 12 over 5, which implies then lambda is 6 over 5. Okay, now what you need to do now is to check if it works in equation 2. Right? So check in 2, and we're expecting it not to work, right? So left hand side will equal in 2, 3 plus lambda, so 3 plus 6 over 5. Okay, so my calculator, that comes out to be 21 over 5. And then the right hand side will equal to 7 plus mu, so it'll be 7 plus mu, which is 16 over 5. So do that on my calculator, and it comes out to be 19 over 5. Now they're not equal. They're not equal, and because they're not equal, you can say that the j's will not intersect in that case then, right? So we can say that lines do not intersect, because they do not work in all three equations. Okay, they're not consistent.